Good morning, welcome to TechCon. I'd like to start with some, as you know, a little bit of history. I like doing history. And we came about from a spin out from the British Broadcasting Corporation, who wanted to do a home computer for schools education. So it's back in 1981 when programming for kids was a bit of a novelty, and the company I worked for got selected to design an 8-bit micro for home computers. And out of that came the need for speed that we all understand. And in '85 we actually had our first ARM processor, the ARM1. And 5 years after that, ARM, the company, got spun out, and in about 2.5 weeks' time, ARM will be 25 years old. And so we're having a bit of a celebration here on the floor show. We'd hopefully you'll join me and Simon there. And, you know, to mark that kind of 25-year anniversary, we're kind of back to the beginning. There's another BBC project, and again, it's a schools education project. The difference here is the BBC Micro cost a few $100s, which was an awful lot in 1981, and the BBC Micro bit cost literally less than $10. And it's cheap enough that we've actually set it up, and there's a group of people come together, and we're giving away 1 million of them free to all the 11 and 12-year-olds in the UK. So every school kid in the UK is going to receive a free microbit to help kickstart perhaps the next wave of computer programming. And, you know, sometimes I wonder where my life has gone, because that's kind of 30 years of designing ARM processors. And if you look from the beginning with ARM1 through to kind of Cortex-M0, which is what's in that microbit, it's basically the same kind of design complexity with basically the same kind of design team. And you can see Moore's Law has driven us down from that 3-micron design down to 20 nanometers and below for today. And so, you know, we thought, well, why don't we do a kind of, 25-year anniversary edition Cortex-M0, and to remind ourselves what it was like to design, and we kind of picked 2-micron technology and 6-inch wafers, and so we put together a little SoC, and I've got one here. So, you don't fit many SoCs on a 6-inch wafer in 2 micron, and it's a Cortex-M0 and enough memory and enough I/O to boot it up and make an LED flash. But, the reason I think this is quite a fun 2-micron design is you can't really do this very well with silicon. Okay? Because it's not silicon. Okay? It's plastic. So it's plastic transistors. I'll be frank with you, it's pretty slow. It's NMOS, haven't got to CMOS yet, so its power dissipation is, not the best. But if you take it out of this, it's about the thickness of Glad wrap, cling film. It's really thin. You can wrap it around packaging. You can do all kinds of things off it. You can run it off a battery. You can ingest it. You can't digest it. I'm glad some of you understand the difference. And if you look at it, we're on a Moore's Law. It's kind of actually imprinted rather than printed. So you can do it with inkjet technology. This is actually imprint with deposition. It's very similar to the technology that's used to make compact discs. It's the same deposition technology. And if you follow it through, you can actually see the advances that have gone from CD to DVD to Blu-ray. You can kind of see how we'll be able to take what is either a very small or a quite complex design and push it through Moore's Law, and we'll be building in 5-10 years' times, those kinds of circuits. And for me, it opens up a whole new world of computing. It's never going to compete with silicon. It's never going to have the density. It's never going to have the speed and performance. It'll always be about 20 years behind. But it does open up a whole load of applications that I don't think you could access with today's technology. And that's part of what I'll talk about today with IoT, where that goes and how there's actually an awful lot of innovation in front of us. It's not just about driving down to the smallest geometries to put more transistors on. There's some really innovative things to do when you tell guys, you've got 100,000 transistors and that's it. What are you going to do with 100,000 transistors? And that's what I like about the Cortex-M0. It's exactly the same as the original ARM one, but it's completely different. One was solving a general purpose problem, the other's trying to be a microcontroller. They both look like ARMs, but actually the architecture's moved on a long way. And again, it's, you know, a few 100,000 transistors, you can do an awful lot of innovation. However, the world we know and understand with Regulus Moore's law has given us all of this, from sensors to smartphones to servers, and it's allowed us to have that kind of ubiquitous presence. So I'd like to just take a moment to talk about servers. And, you know, we've been talking about them at ARM now for a few years, and I'm glad to say that, you know, standing here today, we now have ARM servers shipping from a wide variety of manufacturers, using silicon chips from several different manufacturers. So we've got that diversity. They don't all look the same. They're not all targeted at the same performance, the same use cases. Is it more storage? Is it more networking? And I actually think, you know, we're on the cusp there of having this whole plethora and diversity of ARM-based servers to actually transform what happens in that marketplace. And, you know, to show our commitment to that for a few months now, but to be honest, we've been making sure it's reliable. We've actually been running ARM.com on ARM-based servers. So with a group of our partners, we actually pulled together what is commercial hardware that you can go and buy with commercially supported platforms, and actually put together a commercial-grade website serving millions of hits, and you can make that run. You can actually, as we have, try to achieve some of our targets for CO2 reductions by bringing more efficient ARM-powered compute to the marketplace. You know, it's real, it's something you can do now, and it's something that we're committed to rolling out more and more into the future. Now, of course, it's not just about servers, because when you look at it, it's actually about everything from network infrastructure to wireless access, and this is a Cavium-based Cloud RAN board, and it's where the ARM business model with its partnership allows you to actually have very diverse pieces of silicon being put into very, very different products that scale all the way from, you know, scale-out servers at one end through to very, very specialized and dedicated networking and wireless infrastructure components. And, you know, that wireless infrastructure is a market segment that we're going to have, you know, 20%, 40%, 80% market share over the coming 5 years. So for us, it's really exciting to see ARM 64-bit technology actually pervading out from what is our traditional sensors through to smartphones and really going on and pushing out all the way to servers. But of course, it goes beyond servers, and I have to say, hands down, the Spanish win in the stylish war for high-performance compute. So this is the Barcelona Supercomputer Center with an ARM-powered supercomputer. It's an absolutely fabulous building, and nobody should really try and compete with that. I'm sure they will be much more technically worthy, and the projects we're running here in the US will deliver probably bigger, more scalable systems, but I'm not sure they're going to be quite as beautiful. So, as I say, everything all the way through to high-performance compute, real active programs with real commercial deployments. I think, you know, this is the year that ARM-based 64-bit servers really has arrived. So, I guess I really have to talk about smartphones. You know, we have some reputation in the mobile industry, so I thought I'd tackle that. And I think what's clear in just 5 years, if you ignore simple phones that have shipped in billions for many years, it's where we kind of won our traditional market share, and just look at smartphones. In 5 years, we've gone from, you know, parity between smartphones and classic laptops through to a world that is unquestionably dominated by ARM-based mobile compute with ARM-powered smartphones, the majority of those tablets, and pushing down as well into some of those laptops. And so if you look at that in 2014, more than 85% of all mobile compute was based on ARM. It's the platform that people are now developing for. It's what the expectation is for what you'll get from a mobile compute experience. For me, what I will confess has been more of a success than I had ever imagined. That's partly because maybe I'm a technical guy and I've left my marketing world behind me, is that by the end of 2015, over 50% of that will actually be 64-bit ARMv8-A architecture based. So not only has it transformed, it's moved the 64-bit architecture through, and that is the platform that drives on the future. Now, we all know that in those years we have had phenomenal growth in the number of mobile computing units shipped. The CAGR has been really great. It's driven the industry, and it's been wonderful for us all. And if you look forward into 2020, the growth rate's not as high. It's coming down to probably less than 10%. But even at 10%, that is a phenomenal number of units shipped. Now, everybody likes to talk about the top right hand. And some of you know I tend to kind of go in the opposite direction. So what I think is interesting about that is, out of all of that growth, actually over 1 billion of those smartphones that will ship in 2020 will actually be really low-cost entry phones. So I'd like to just take a moment to sort of look into that kind of mid to low end of the smartphone market, which is often neglected because it's not about the latest, the greatest, the shiniest, the most expensive, what you all want under your tree at the end of the year. It's actually about something that's closer to the real world and real life. And I think it's quite clear that the mass market mobile first has actually changed the world. And so as an industry, I think we can be proud about that. It's one of the things where it really has transformed people's lives, and it's not just the rich and wealthy, it's actually the poor and needy. And that mobile-first revolution has actually changed people's lives, will continue to do, and I think is an important part of the investment that we make. And we could talk all day about what's actually happened in education, the transformations the smartphone has brought in healthcare in rural areas with the access to that technology. But what I'm going to talk about is actually Cortex-A35. So we're announcing today a new CPU targeted primarily at that mid to low range mobile space. So it's 64-bit capable, fully backwards compatible, runs 32-bit if you want to, so 64 and 32-bit. It's 10% lower power at all the same criteria as the Cortex-A7. And without being marketing, at the same time as you get that 10% lower power, you get a performance uplift of 6 to 40%, depending if you want to look at SpecInt or whether you're running Geekbench, which kind of shows what you can do with benchmarking. Two ends of the spectrum, two reputable benchmarks telling you two very different things. So you get lower power and higher performance at the same time. And equally importantly, it's a very, very flexible piece of IP that's really, really scalable. And I'd like to talk in for a minute about the kind of the scalability that means you can use one IP platform to actually deliver a range of products, and it goes well beyond just the mobile platform. It can be used in a lot of high-end embedded wearable technology. It is actually a truly remarkable product. So if you look at two configurations, a typical performance-optimized 1 gigahertz core, and compare that to a targeted low-end, low-power 100 megahertz implementation, there's over a 15 times ratio on what the power consumption is. And I think that just demonstrates how flexible that piece of IP is. It moves you all the way from 90 milliwatts down to less than 6 milliwatts, depending where you want to make that trade-off in performance. And another way of looking at that problem is to say, just look at the size. You can configure this as a quad core with big level 1 caches using the full Neon SIMD architecture, the hardware encryption extensions, a large level 2 cache, and with the same RTL, you can actually generate a single core configuration with an 8K cache and no level 2, and you see that 10 times ratio in area. So you really can take that and scale it from the cheapest phone right the way through to a mid-range phone, or push it into your wearable or your embedded high-end IoT device. So a wonderful piece of very, very configurable technology. It's not about the headline-grabbing numbers in terms of world's fastest, but it definitely is most efficient and most flexible. So that's the Cortex-A35. Very proud to announce that product today. But of course, it's so much more than just processors. We've moved into a world where consumer products are kind of going on an annual tick. We've reflected that in our roadmaps. We've accelerated the investment we're making in all of the IP that we develop. It's about graphics, it's about video, it's about the display technology that goes with it. There's the whole system IP components, and of course physical IP that underpins this. And this is just a kind of simplified view of the products available today and their future roadmap and our commitment to it. So, as I say, ARM, more than just about the processors, it's about all of the IP and the package that you need to build those products that you want. Now people kind of go, well, it's the mobile industry, it's got a bit boring, it's got a bit flat, where's the excitement? I actually think there's a wonderful opportunity for innovation. As we start to have more and more touch points in our life as we move into wearables, combined with the infrastructure around us, combined with that mobile phone, for ARM, it's about having the right compute to do all of the different tasks. And I think our devices do become more contextually aware. We're seeing more and more natural language processing. We've got advanced machine learning. And while a lot of that is done back in the cloud, it also at the same time drives the complexity of the end devices, because real-time constraints force you to do some processing locally. It cannot all be done up to the cloud and back again. So I think there was a real opportunity for innovation in the devices as well as the services that go from that. And in 2020, the mobile phones we're using then and the smart devices we have around us will show incredible innovation based on what we have today. So, opportunity to talk a little bit about sensors. Now, this is my favourite product this year, only available as a prototype, you can't actually go buy it. It's a Bluetooth LE connected insulin pen to help with diabetes monitoring. Okay, not that exciting, you say. There's been quite a few things about products like that. What I think is actually really, really exciting about this is it has no battery. It's powered by the energy you provide by pulling off the cap. So it's a piezoelectric system, you pull off the cap, that generates enough electricity to do the analysis of your sample, a short Bluetooth LE connection to transfer it, and then you're done. You put the cap back on, and then when you come to take your next sample, you pull the cap off. And I just think, again, like my plastic electronics at the beginning, starts to open up new possibilities of things where you don't have to worry about the battery life. Now, you have to have a simple, self-contained problem to do it, but I think there'll be more and more examples about that. So for me, this is definitely product of the year because it shows that possibility of innovation that comes once you're removed from some of those constraints about how do you make it chargeable, where do I charge it, when do I charge it, all of those anxieties that some of you are already probably starting to feel at 10 o'clock in the morning. So, 1981 through to 2015, what's changed? Well, one thing that's changed is we've primarily gone from devices that were standalone, discrete, through to a world where everything is internet connected and enabled and communicating. But I think the real change is, having done that, is we're under attack in a way that we never were before. And the reason I raise this is I was the ARM Global Engineering Conference first quarter of this year. And I don't know what your companies are like, but in us, some of our engineers are perhaps a little bit more looking at their shoes, slightly more inward focused, a little less open and communicative. So as an organising committee, we thought, well, okay, how do we drive engagement and conversations and all those wonderful things? And so the answer, of course, is we have to deploy an app, and the app has all the usual things about here's your timetable and the sessions you can go to and all of that. But it also had a scoreboard. You could get points if you reviewed a talk, if you shared a post, and it was to try and drive some kind of social interaction and communication. So at the end of the first day, I was sitting down at one of the tables having dinner with a few of the guys, some of whom are here. You ought to be careful. Who work in the IoT BU at ARM and are interested in internet security. And I asked them, how secure do you think this app is? And they looked at me and they lit up. It was kind of, we don't know. We thought you wouldn't approve, so we haven't looked. So I said, well, you know, I'll give you tonight. Why don't you go and have a look? And so I met them for breakfast the following morning, and they said they'd only spent 3 hours on it. But this is what they'd found. And I thought I'd just share what they'd found. And so they explained that, you know, okay, here's my phone, it's running an app, there's a server with a certificate, the certificate is checked against the certificate authority, the traffic's encrypted, you can't tell what's going on. It's an Android app, so you boot it up on an Android emulator and you insert an SSL interceptor in the middle and you kind of go, let's see if we can do a classic man-in-the-middle attack. Now, we've all heard the words, but what that means is you intercept the certificate that comes from the server, and you use that to encrypt the channel between the interceptor and the server, and you insert your own certificate authority on the device. You insert your own certificate on that channel, and the phone checks that certificate, bogus certificate against a bogus certificate authority and goes, that's good. And that communication is now unencrypted, and you can see everything that's happening on the channel. Why the hell does it happen? Well, the world's difficult. The app's deployed in lots of different countries. Which certificate authorities are available where? I don't really know, so why don't I just trust the phone? And all it takes to fix this problem is to decide, who do you trust? And the answer is, you don't trust the phone. You trust a particular certificate authority, you specify who it is with one extra call, and then the hacker can't replace your bogus, with a bogus certificate authority. Simple to do, people don't do it because deployment is actually a difficult problem. So, they can now see the channel, it's all clear. But you can't do very much. You see the messages going by, but I want to actually do something. I think I better log in and try and generate bogus traffic. Now, they've got this right. It was protected by a shared key. Don't know what the shared key is. Can't break the encryption because we're not a government body. We don't have the time and the compute resources. We're stifled. We can't actually log in to do anything useful. But then you think, well, we'll just have a look at that package that we downloaded from the Android store. And lo and behold, that package contains 2 files. It's got the application code and another one presumed to contain the shared app key. And lo and behold, it does, in plain text. So now you think, oh, okay, I've got the shared app key, now I can log in, the world is ours. And, you know, why did it happen? Again, provisioning is hard. App is developed here, app is deployed there. Each company wants its own app key, so my app doesn't talk to the company next door that's running a conference in the same venue. We'll leave it to somebody else to actually come up with a scheme of generating these app keys, because it's really not that important, is it? And, you know, there was a ton of other mistakes in that application. But we're not quite done yet, because, okay, now I can log in and do stuff. Well, what am I going to do? Well, I wanted to get to the top of the leaderboard. Well, to get to the top of the leaderboard, you have to post things. Well, I could have posted things because message replay was broken. I could have just reposted the same thing. That's not very cool, is it? So I could post new messages now. Well, how am I going to generate content that doesn't obviously look as though I'm just a computer generating content and posting rubbish to get noise? And this is how a hacker thinks. okay? And this is the bit about this that I was truly impressed. They kind of go, oh, post, win points, repeat. I wonder, is there a delete command? Never seen a delete command go across, but why don't I try spoofing delete message? And lo and behold, there is a delete command. Never been seen, just assumed there would be. Somewhere in the API, somebody thought it was useful, let's have a delete command. So now you can go post, win point, delete, repeat. And I must confess, for 2 days at the conference, there were people there busily making posts, going up the leaderboard. Surprised that some people managed to always stay just behind them, until the last day when, of course, all of a sudden, they go to the top. So, why am I telling you this story? Well, this was an app put together by a non-trivial company with serious funding. They got most of their security right, okay? They basically knew what they were doing. They got most of it right. They made some mistakes. And this could have been an IoT application. Happens to be running on a mobile phone, but it could have been any old IoT application. So, well-funded company with serious people who knew what they were doing. Our challenge is how we make $1 microcontrollers more secure than that, developed and deployed by people who probably have no security experience whatsoever. And the reason I pick $1 is, look at the microcontroller that's going to go in a $10 light switch, okay? How much time, money and effort as a designer, manufacturer am I putting into that kind of $1, $10 product? And then think it's moderately successful. And I deploy, 100,000 of them in the Bay Area. And they each control, a 50 watt light? That means as a hacker I can kind of go 5 megawatts on, off. On, off. What do you think is going to happen? Right? So at scale, you really have to worry about this stuff, and it's built on $1 foundations. That's the problem we're trying to solve in IoT, and some of it is about removing constraints, okay? Here's a completely general purpose solution. It's called a microcontroller. Program it any way you like, do what you like. You're not going to get secure solutions. You have to build constraints, you have to simplify it, you have to build a platform that makes choices. They may not always be the choices you want, but they're going to be choices that actually allow you to build secure platforms that reduce the probability of hacking. Are they going to take it to zero? No, they're not. But it's a question of how can you reduce that attack surface. So that fundamentally is the problem we're trying to solve. And it starts at the bottom with the device integrity. It goes through the communications and goes right the way to the top to the life cycle. Because there's no point having a secure device which you then quite happily re-flash over the internet to discover that you've downloaded bogus firmware that then roots your device. Okay? So it has to go across the whole life cycle as that product as it moves through manufacture, distribution, deployment, and reuse and repurposing. So that's the problem we're trying to solve. And, take a trivial example of that $1 Bluetooth-enabled microcontroller out there. Fortunately, you made the right decision. It's based on an ARM Cortex-M processor. Very fortunate choice for you. And I'd like to show some of the things that we're doing to help in that design. And today, I'm also pleased to announce that we're launching the ARMv8-M architecture that will build future generations of our microcontrollers on. And that new architecture brings instruction set improvements to enhance the efficiency of some of those embedded tasks you do. But perhaps the most important part of it, it brings Trust Zone, which we've had for some time in our A class. It brings Trust Zone into that low-cost, embedded, real-time M-class world. So it's a whole new security foundation for the Cortex-M processors. Now, you might be familiar with Trust Zone for V8A. It's based on a secure monitor that handles the transitions between your non-secure apps and your non-secure OS with a secure application which may be running video encryption, it may be payment, and a small, tiny, secure OS. And then there's a monitor running in secure side software that's quite flexible, allows you to build several different models, allows you to use the full richness of the Cortex-A, so the ARMv8-A architecture. And it does everything: authentication, payments, enterprise security, content protection, whatever you want it to do. So we've taken that philosophy and that design, and we've kept most of that. And what we've done is we've transitioned that into ARMv8-M, and have replaced the secure monitor by actually hardware. So the transitions from between the non-secure app and a secure app, or a non-secure app through to the RTOS, not quite the same flexibility that you have on the full trust zone for V8A, but again, it does the job for those M-class devices. And because we've built that in hardware, it's optimized, it's the right thing for real time, so it's low latency, it's deterministic, it's highly efficient. You can fully program in C, you don't have to get down into assembler to use any of this stuff, fully programmable in C. And actually, the whole debug architecture is thought through, because you need to be able to way of doing secure debug that isn't a back hole into your whole secure world. So secure debug is part of the architecture. So Trust Zone for V8M actually now allows you to build some of that integrity into the low end of your device, which gives you separation and isolation from the apps that you're running on your microcontroller, which may not have been written by you, may have been downloaded, or you maybe want to just have that separation between the critical parts of your code and the less critical parts of your code. So very pleased to announce ARMv8-M architecture today. So that's allowed us to further secure your Cortex-M device. You obviously have a whole load of use cases that you'd like that hardware to do. And therefore, I'm also happy to announce today Cryptocell. And Cryptocell is actually two families. It's the 700 series and the 300 series. The 700 series is larger, more complex, is probably more suitable for Cortex-A implementations, but the 300 series is squarely targeted at those Cortex-M designs, and it allows you to have those security resources. It implements the acceleration for asymmetric crypto and symmetric crypto, so it gives you those hardware building blocks that you need in order to be able to secure those different use cases. So, that's the hardware. And as most of us in the room know, the hardware is the easy part. On top of that, you actually have to deploy your software and applications and services. And last year we announced Mbed OS. Now there's Mbed OS 3.0. Go to mbed.com, it'll point you to the GitHub you can download and start playing with today. It uses those security concepts in the microvisor, which embeds some of the lowest level security to where we've architected for people. Do it this way, use these APIs, and we've made the trade-offs and the choices for you. On top of that, it looks like a more conventional world with a set of device drivers, support for the different communication protocols, and then on top of that, the core part of Mbed OS, and then Mbed TLS, so actually you can do that communication security implemented in the upper layers with the fundamental security in the lower layers. So we've shown an example of how you take a protocol, you separate out those things that must be secure, that you do in the microvisor, and those things that are really just flow control that you can do in higher levels of the stack, so you move it into user code effectively. And then on top of that, the repositories for the libraries and the application codes that you develop. Now, last year I explained how you connect those small OSs through to the cloud, and that you need a way of securing the communication on that side, and how on the cloud you want to present a unified world for the whole diversity of 1,000,001 different microcontrollers and products that exist in IoT on the left. But on the cloud side, you want to have a simplified view of the world of devices that you believe are always on and always there, even if they're actually powered off or on very remote, high latency, low bandwidth networks. So creating that cloud-aware representation of the devices running in the cloud was the Mbed Device Server, part of the IoT device platform. And again, what I'm very pleased to announce today is we've taken Mbed Device Server and made it available as a web service. So you can go to mbed.com, there is a connector service there that without you having to install any software yourself allows you to connect your Mbed OS devices into the cloud and point them at wherever you want the data to go. So it's a way of us trying to make it easy for people to do deployment of IoT at scale. If you want to then take that software and bring it on-prem, you can. If you're happy to use it in the cloud, you can. And for development purposes, we're making it free so that you can get up and running as soon as you can. And it's all about allowing you to design your IoT device, connect your device to the cloud, which means connecting it and pointing at somewhere that will actually utilize the data. You then have to write the app that will analyze that data, and you need to then have it connected in through whatever cloud service provider you want, where you'll be running your data analytics or whatever your application is. So it's about connecting those devices to those cloud platforms for you to be able to do your analytics. And next year, you'll see us roll out more and more of those services so that we can make it easier for you to provision all of your devices in a scalable way rather than what you can do at the moment, and to update your devices securely, manage them, and make sure you're pushing latest updates securely to all of those devices. So they're services that you'll see evolving next year. And it's all about reaching developers. You know, in the old days, it was all about lovingly crafted machine code. It then moved to a world of, C-based development, but now we're talking about a world where apps developers expect to live in a kind of a mobile world, and there are millions of application developers out there. You need to make this world look like a mobile web world. That's what means it's IoT rather than embedded control. Embedded control is kind of what's on the left-hand side. For us, it's all about scaling it to make it look like that mobile web-enabled world. They're the developers out there that are going to drive most of the innovation, I think, in what the new products are in the future. So, today I've talked to you about Cortex-A35. It's all about scalable, efficient processors for that mass market of mobile. We've actually written a little Mbed OS app that runs on those mobile devices, and you can use that Mbed OS app to actually provision your IoT device. It's not the full web scale servicing that comes next year, but it's an app that actually allows you to use Bluetooth on your phone to enable and provision your IoT device. And the classic thing you're doing at that point is, I bought my consumer device, how do I get the Wi-Fi code into it, right? And that is something that you can easily do from your phone, which knows it and allows you to pay and do that, while talking up to the web, so it does actually know what's this device, what was your phone, how do you join them together. So a web-based app that allows you to do provisioning of IoT devices. Those IoT devices, I've talked about ARMv8-M, the security enhancements that we're bringing to that, Cryptocell to embed that security so you have a low-level root of trust within those devices, and of course Mbed OS and the development environment that goes with that, the whole community that goes with that, that makes it easy for you to develop and share code if that's how you want to do your developments. And over today and tomorrow, there's a whole track on Wednesday on the Mbed platform. They'll be talking about the reference designs that we've done for simple wearable devices, 6 low-pan devices, and one more I can't immediately think of. And so that's an exciting announcement that you'll see tomorrow, today and tomorrow. And then beyond that, Mbed Connector, that integration into the web that lets you transition from the client devices on the left-hand side through to those cloud applications, and hopefully more and more of those you'll see will all be running on ARM-based servers. So, quite a diverse range of things. Hopefully you'll find that something in that is exciting for you, and you'll find the time to find the tracks on any of those to go and find out more about the technical details of those products. Now, what I haven't talked about is the stuff in the middle. I haven't talked about that because marketing said, well, Mike, you can't do sensors to smartphones to stuff to servers. It's just not professional. So it was kind of like, well, I can't think of another S to come up with that comes up with that. So if anyone in the audience comes up with a better S for all that stuff in the middle, then next year I promise that's what I'll talk about. But this year I'm not going to. So what I'd like to finish with is, what's changed? Well, in the early days of personal computing, it was all about performance per dollar. It then became performance for power times dollar. And then the thing I think ARM did back in 1990 that changed that equation is we realized it wasn't about power, it was really about performance over energy times dollar. It was energy that mattered, not power. It wasn't heat dissipation, it was actually battery life. That's what we were set up to do. So we kind of changed that world to performance by energy by dollar. And I think there is one more change in this equation, which is what it comes as we move into the Internet of Things. And that is, you've got all of the problems that you had of all of the generations before us, and I think it's a multiply, but I did question whether it's to the power, and I'm not quite sure, but it's at least linear, but it may be exponential, and that's times trust. And I think that's what's changing as we look at these systems. You have to build them secure, but the security is there so that you can trust your devices, because what you need to do is now share that trust around you. You need to trust that the transaction I'm going to do with my front door lock, with the key, the virtual key that I give to my neighbor, that what is the trust relationship between that? How do I mediate trust to do updates? How do I mediate trust down a manufacturing, distribution, installation, maintenance, decommissioning? How do I manage it across a range of different people with different verticals interacting? And I have to pass that trust around. So we need secure platforms to do that, but it is ultimately about understanding who can you trust with what, and what are you prepared to do when you don't trust them. So as I say, performance divided by energy times dollars times trust. And to finish, I still think there's an incredible amount of innovation ahead of us in semiconductors. Whatever people say about Moore's law flattening, cost of fabs going exponential, they're all problems, but they're all merely different sets of constraints. We've always had constraints on what we can do. And even with those constraints, people come up with innovation. And if you just look across all of the different areas that we know silicon goes in today, if you think through to where those plastic transistors are going to go tomorrow, I think there is an incredible amount of innovation ahead of us. And there is no shortage of that to share among ARM, the partnership, and all of the good things you do and we do together. So with that, I'd like to thank you all for coming. I hope you enjoy the rest of the day here at TechCon. Come back tomorrow for more of the lectures and the floor shows that will be open then. And thank you very much indeed.